Hello, my name is Ivan Smirnov. Welcome to Getting Started with Generative AI and Research. So in this video, we continue to talk about technologies that are behind generative AI. We already discussed what AI or artificial intelligence is, and now we'll be talking about ML or machine learning. Machine learning is an advanced field in computer science. However, conceptually, it's actually quite simple, and I would like to give you this conceptual understanding of how machine learning works. So let's consider this simple example. Let's say we just have two variables. One of them is GDP per capita, and another variable would be life expectancy. So we will use countries just from one region and just in 1 year. So now let's try to do linear regression. That's probably the simplest statistical model that you can encounter in science, and you're probably familiar with it. But if you're not familiar, then the idea is just you're trying to draw a line through these points, but not like randomly, like this or like that. You try to draw it in such a way that it fits the data as accurate as possible. And what exactly it means that if you compute these arrows between your points and the line, and you take the sum of their squares, it would be minimal. And the regression is a very common instrument, for example, in social science. And usually what you do with regression, you're saying, okay, if the slope of this curve is positive, it means that there is a positive relationship between life expectancy and GDP per capita. But also linear regression is the simple machine learning model, because once you plot this line, what you can do, you can now take another country, and let's say that for this country we actually know only GDP per capita, but we don't know life expectancy. So we now can just use this line to predict the value of life expectancy for Germany. And in this particular case, it's actually a quite nice prediction. So we would predict using this line that life expectancy in Germany should be 78.92 years, and the actual value is 79.41. So it's like even within an arrow, and the actual dot is here. So more generally, what we just did, we used a very simple function, just linear function, y equal to a1 times x plus a2. Then we used some training data to find parameters a1 and a2 in an optimal way. So in this case, we just determined the slope and intercept for our line. And then after we did this, we just fixed this a1 and a2, we fix this line, and we can use it then in the future for other x values to predict y. So in our case, we used different values of GDP per capita to predict values of life expectancy. So this function is very simple, and the data could be more complicated. So in some cases, instead of a line, we want actually to draw like a curved line through the data points. In some cases, it's not enough to have one predictor, but we might have a couple of predictors. So there is like generalization of this model, but the idea remains the same. So you always have a function, and this function has some parameters, and it has some input values. We use training data to compute these optimal values of parameters a1 to an, and then we fix them. And now this function with 6 parameters can be used for new values of x to predict y. And that's actually exactly how all these like complicated large language models work. They may sound like they're very complicated, but it's also just a function. So for example, if you hear that, Meta introduced a new model called Llama, and this model has 405 billion parameters, what it actually means that they released this function, which is much more complicated than linear regression with 2 parameters. It actually has 405 billion parameters, so it's like a huge function, but it operates in the same way. So they use some training data to find the optimal values for these 405 billion parameters, and now you can just apply this function to your own data and to get new predictions. The only important difference between our example and this more complicated function is that in case of linear regression, it's actually possible to compute optimal values of parameters. There is a mathematical formula for that. And in case of more complicated function, it's impossible. So instead, people start with random parameters, and they send training data chunk by chunk, and each time they update parameters, so they're becoming better, and the function returns results that are closer to desired outcomes. And for modern models, for these complicated large language models, this training phase could require you months on a very powerful computers. So that's not something that you can do on your own computer, and that's not something that can be done immediately. But overall idea remains the same.